In most of the remaining videos, we're going to look at factoring quadratic expressions. So what is a quadratic expression? Let me write down an example of one. If I wrote 2x squared minus 5x plus 4, that is a quadratic expression. If I set it equal to something, if I were to set this equal to 0, then my quadratic expression becomes a quadratic equation. If I get rid of the 0 and say y equals that, then I have a graphable relationship between x and y that could be described as quadratic or parabolic. The graph of this would be a parabola. These expressions are important because aside from a linear graph, a parabolic graph is about the simplest graph that we can make. So what makes an expression quadratic? A quadratic expression is a second-degree polynomial. Just for reference, if I were to have a linear equation, y equals 5x plus 2, the expression on the right-hand side would be a first-degree polynomial. But we all know that that would give us a linear shape if we were to graph it. So first-degree polynomials will be linear. If we graph them, second-degree polynomials will be parabolic if we graph them. But what all of these have in common is they can be written in the form a times x squared plus b times x plus c. Now, hopefully we know that while I wrote x, that could be any variable name. It's very common to have something like t for time there instead. So x is the variable name, and a, b, and c are coefficients. So a, b, and c equal coefficients, and coefficients are numbers that can be written in that we may or may not know, but they're representative of fixed numbers where we could be substituting all possible values in for x. If we were graphing it, we would have all real values going in for x, whereas a, b, and c would remain fixed. It's a lot like y equals mx plus b, where x can vary, but m and b are fixed numbers for any given line that you graph. So we just use a, b, and c because they're in alphabetical order. So other examples of quadratics, I could put in any values. They don't even have to be integers. So it could be, 3.7 x squared plus 2.5 x minus 1.2. That would be a quadratic expression as well. We're mostly going to work with integer coefficients, but they don't have to be. Sometimes you might see a quadratic that looks like this. It could be 5x squared minus 2. And when you have that, it means that the a value would be 5. You don't see a term for x. So what that means is that the b value is 0. And since it's supposed to be plus c and we have a minus 2, c must be equal to negative 2. I also could have a quadratic that looked like 5x squared minus 3x. In this case, a would be 5, b would be negative 3, and yes, that's correct, and c is 0. As a final example, if I had 2x plus 7, while you could treat this as a quadratic where a equals 0, if a is 0, we would say that it's not quadratic. So it has to be a second-degree polynomial in order to be considered a quadratic expression.